Very good. Hi everyone, my name is Ron Hussain. I'm one of the technical experts at Soft. I specialize in product demonstrations. I'm also technical account manager, so I also help in regards to product evaluation. And if you have any questions, any issues, I also oversee. I also take care of those situations as well. Uh, Today, we're going to go ahead with the topic. We're going to cover this webinar, and the topic that we've selected today is 6 tricks for optimizing NCache performance. It's an NCache topic. Typically, what we do is we cover general technologies such as distributed caching, scalability, or performance, or entity framework. But we talk about the technologies in general, and then we use NCache as an example. But today, what we've decided is that we'll cover an NCache specific topic, where we'll cover some deep details about NCache performance features. For those of you who already know what NCache is, NCache is already our performance solution, but in this webinar, we'll talk about tuning performance to some more levels. So we'll talk about some performance features which you can use to help improve performance even more. Mode of this webinar is going to be listen only, which means I'll be doing most of the talking. But you can always participate. You can ask as many questions as you need to, and for that, you can see on the right side of your screen there is this questions tab. So if you can expand on it and then type as many questions as you need to. And that's a quick way to interact during this webinar. I want you guys to post as many questions as you need to. Keep it interactive. Stop me whenever you need to, and I'll keep an eye on it and answer all the questions that you guys would post. So just for the sake of confirmation, if you can see my screen, if you can hear me fine, everything is set up properly, just give me a confirmation using the questions tab. And that would just serve as a reminder that you can ask questions whenever you need to. So please let me know if everything is configured fine, and we'll get started with the topic. All right, so I've got one confirmation. Yeah, so hopefully rest of the recipients or attendees should be able to see the same kind of behavior. I think we're good. So let's keep your questions coming. Ask as many questions as you need to, and we'll quickly get started. All right. So I see some more people have joined in. Thank you very much. My name is Ron Hussain. Let's get started with the topic. So coming back to the topic today is 6 tricks for optimizing NCache performance. So it's a hands-on webinar. I'm going to talk about 6 different features within NCache. And those 6 features would help you optimize NCache performance in your environment. You can just turn these features on. Some are configurational based, and some are specific APIs, the right API. So just by the correct selection of the APIs, you can see you would see that you would improve performance inside your applications. And I've designed this webinar in such a way that I would just create a baseline. I would run some tests, get some performance numbers with default settings, and then one by one I'll talk about these 6 features, and I'll show you the performance before and after turning these features on and off. So that's what we have in agenda today. And like I said, please ask as many questions as you need to. Keep your questions posted. All right, so let's get started with this. For those of you who already know what NCache is, must be aware of NCache deployment. Just for the sake of completeness, I'm going to build some basic concepts about NCache. NCache is an in-memory distributed caching system. It's a repository where you can put your data, and everything is stored in memory. So it's already fast in comparison to your database. So one of the core benefits of NCache is that it improves your application's performance in comparison to database. And next thing about NCache is that NCache is a distributed data source. It's a distributed cache. It allows you to add as many servers as you need to, and your request load from your application side is divided between the available number of servers. And you can add more servers on top of it. So it's very scalable as well. So these are the 2 benefits, primarily performance and scalability, and these go side by side. And since we're talking about performance features within NCache, so I wanted to highlight this. NCache already is a performance solution in comparison to database. Whenever you put NCache in place, whenever you deploy NCache in your environment, as you can see in this diagram, we have NCache in between your application and the database. You're essentially saving your trips to the backend data sources. Data sources are slow, and under peak loads, they tend to choke down. In comparison, NCache is fast and it's very scalable. It can handle linear, more and more requests, load from your client applications. And as you add more servers, you get linear improvements in regards to capacity of how many requests you can handle. And today we'll talk about the baseline numbers. We'll talk about having NCache in place, setting up the environment, and then we'll start with basic features one by one and demonstrate how you can further tune performance on top of what you've already achieved. So let's get started with this. These are some system requirements for NCache. NCache can be installed directly on the web servers or on the separate boxes as shown here. It can be on any Windows environment, 2008, 2012, 2016. Only prereq for NCache is .NET 4.0 at the minimum or later. And it runs on all 32-bit and 64-bit machines as well. You can install NCache on the same boxes where your applications are currently running, or you can install NCache on separate dedicated boxes as well. So it's entirely up to you. It's very flexible in terms of deployment. As far as hardware recommendations are concerned, more is better. NCache relies on CPU, network, and memory resources. So CPU and network is something that NCache would actively use because it needs processing to process your request and the data. It needs network it uses TCP/IP sockets, so network is very important factor. And RAM is actually something that is based on your data requirements. So whatever data that you need to add into the cache, you need to have the capacity for that in terms of physical memory. Everything is stored in the memory of the caching service. And on the client side, you just need .NET 4.0 or even older ones would work. Servers would need .NET 4.0 or later. So I've already installed NCache. Typically, what we do is we go through 5 simple steps to getting started with NCache. That's usually covered in our regular webinars. That's already been done in many of such webinars, so I'm not going to go into deep details in how exactly you would go about configuration. But today I would just show you how to set up the basic environment. So I'm going to go into my demo environment without any delays. And what I'm going to do is I'm going to close everything here. There you go. All right. So I have 2 boxes. I have demo 1 and demo 2. These are the 2 servers which I'm going to use for caching. I'm going to create a cache cluster on top of these 2 servers, and my personal laptop right here is going to be used as a client machine. And all the applications that I would plan on that I've planned to run today, I'm going to run it from my machine. And these are very regular configuration boxes. I'm not too sure if these are dual CPU boxes, but these are very regular boxes. In your environment, if you have a better hardware, you're even expected to get better performance numbers out of it. So let's get started. I'm going to use the management tool, a GUI-based management. You can also use command lines, but I'm just going to show you the GUI-based cache creation. So I'll use demo cache. That's the name of the cache I'll be using. Again, I'm not going to go into details on what are the configurations needed, what are the details around these configurations. I'm going to assume that you already know these details about NCache. And focus today would be the performance features, to highlight performance centric features within NCache. I'm going to use our partition replica cache because it's very good for reads, very good for writes, and it's very scalable. So it's better in comparison to other topologies for reads and writes performance, for scalability, as well as for reliability. So I'm going to go ahead with this, keep everything default, choose async, provide the first server, NCache is installed on it, provide the second server, again NCache is installed on it, and I'm going to choose default port. Size 1 gig is good enough for my tests. I'm not planning on adding a lot of data into the cache. I'm just going to experiment with some data, but I'm going to read and update that data quite frequently. And I'm going to keep everything default here. I'll start this cache. I'll pick auto start. That would actually start this cache each time my service gets restarted or server gets rebooted. So your cache are automatically up and running. and that's it. And you must have noticed that I've picked all the default values as far as cache creation is concerned, and that was intentional. I did this to make sure that we establish the baseline with default settings of NCache, and we then build on top of it. We would just turn on one feature, show you the difference, and then we move on to the next feature, again show you the difference. So before and after difference would demonstrate how performance is improving for each feature separately. Now I'm going to add the client node. Again, that's a configuration step. Any box from where you plan on running your applications, you need to add it as a client machine. So I have added my box. Let me just verify the IP of my box. I'm pretty sure this is it. Yeah, 102. So we're good. And next I'll do is I'll start and test this cache cluster that it's up and running and working absolutely fine. If you guys have any questions, although today's focus is not highlighting the cache configuration, but still, if there are any questions, please feel free to let me know. And you can use question and answer tab for that matter. I'm going to quickly test. It's fully connected. Very good. I'm going to start monitor cluster on this. That's a monitoring tool. So it shows me demo cache. No clients are connected. I'm going to bring this right here. Okay, so request per second, and nothing is being done as far as activity is concerned on this particular cache. So I'm going to come here. I'm going to run a stress testing tool application which comes installed with NCache, and I'm going to run it just for the sake of verification that my cache is up and running. So I'll see some activities. I already have a client showing here, and if I just right click, I can see some activity already happening on both boxes. So about 300 requests, 300 to 400 requests per second by server 1, and about the same by server 2. And I will also open performance counters, Windows Performance Monitor, and I'll be using some performance counters at a later stage to see the client side performance as well. All right, so everything looks good. I think we're set up as far as the environment is concerned. Please let me know if there are any questions at this point. I'll be happy to answer those questions for you. But again, let's get started with our first test. And this is not any performance feature. This is to establish the baseline. I'm going to experiment with basic add and get APIs, and I'm going to see what sort of performance NCache exhibits when you run it with the default use case. And for that, I have application written right here. All of my tests are added in this application. So test 1 is something which is going to be in focus. Let me just walk you through what I have in mind. I have main method where I'm using two different kinds of objects, a 100 kilobyte object and a 10 kilobyte object. So these are the two objects that I plan on using for this particular webinar. And then I have object count. I'm mostly experimenting with 5,000 items, but in some tests I'll be using 10,000 items as well. So all I'm doing is for test 1, that's something that I'm going to run next. I'm looping through the number of objects, and in this case 5,000, and I'm adding those objects into the cache. So 5,000 items, 100 kilobyte each, is going to be added into the cache, and then I'm going to read all of these items back. And before and after reading, I'm actually displaying the time it took to take care of that. So that's it. That's my test number 1. All I'm doing is using the basic APIs of NCache, cache.insert, to add data into the cache, and cache.get to retrieve the same data back. And I'm collecting the time for that using the date time now, and you know, establishing two date times and taking a difference. I can also use stopwatch here, but I simply used a very basic way of calculating the difference. So with basic configurations, what I'm going to do is I'm going to get started with this. I'm going to clear my cache contents so that nothing is in there. Cache size 540 is default. It would be picked up as soon as other data would get added. So let's get started with this. I'm just going to run this. I hope you can see my screen. It's right here. And it waits for my input. So I'm going to start adding data into the cache. And if I come back right here, you can see requests per second and additions per second. items are getting added into the cache. And here on the monitoring tool, I can also show you some activity going on. Let me just relaunch this monitoring tool so that it shows the updated view. I've noticed that it sometimes gets stuck. Yeah, so it's now showing the updated view, and we have completed the add as far as adding items to the cache. So about 2805 items on server 1 and 2195 on server 2. Both servers are utilized evenly in this particular topology, and we have backup of server 2 here and backup of server 1 here. So everything looks good. Now what I'm going to do is, I did not calculate the time it took because I'm more focused on get performance for this particular test. And I'm going to retrieve these items back, and it would display the time it took. And you could see activity coming here as well as here. So it's initiating some requests. And on the client side, you also have an ability to add NCache client counters. I'm going to do that so that we have client-side counters for this particular cache. They will not show any activity because my application is done. So it took about 26.7 seconds. I'm going to run this one more time so that we establish that these are exact numbers that we're interested in, and these would serve as baselines. Okay, I've cleared the contents of this cache. I'm going to run it one more time, and let's see how it goes this time. This time I would not focus on the counters. I would just show you the output here and show you the performance counters in this window right here. So you can see client-side counters here as well. Average item size is 100 kilobyte, and then we have average microsecond per insert is about 4,000, 5,000. That makes about 5 milliseconds. So that's pretty fast already in comparison to databases. It's taking about 5 milliseconds to add 100 kilobyte object. And now I'm going to read these items back. And again, you can see that it's taking every microsecond per fetch is about 5. And it's showing you deserialization time, and then items getting added into the request queue as well. So let's see how much performance it exhibits. I'm expecting about 25 to 26 seconds. This was run again to prove that it actually takes this much time each time. So there you go. So 26.5 is our baseline, and this is already pretty fast. Rest assured that if I retrieve the same data from the database, it would take a lot more time than that. It's in memory, and it's using 100 kilobyte object. That's fairly large object when it comes to NCache. All right, so now that we've established that it takes about 26.5 seconds to complete this first test, I'm going to experiment with our first trick. So first trick is to use the client cache. Now, client cache is a local cache. It's without any code changes, you can turn it on. And the architecture of client cache suggests that it's a local cache which runs on your application box, and then it's connected to the server cache. So we have two boxes on the server. We have one client machine where I'm running the applications. I'm still going across the network from my machines to those cache server boxes and getting data back and forth. So that's still one hop away, right? How about I keep a local cache which is in sync with the server cache, which brings the data from the server cache or adds data into the client cache and then in the server cache, so that we have data available closer to our application. So NCache typically saves your trips from your application to the databases. It saves your trips to the database. It keeps data closer to your application in memory. And NCache, client cache on top of it, saves your trips across the network to another cache. So it keeps data locally on your application box. And it takes care of synchronization as well. Any changes that you make in the data in the client cache, those are propagated into the server cache by design. Server cache is the master copy. Client cache is a subset of the data. And whatever changes that get applied on the server cache, those are propagated to the client cache. And this is managed by NCache. You just plug and play, turn the client cache on, and then it gets utilized. Now, client cache has two modes: InProc or OutProc. OutProc would be a one local cache for all your applications on a client machine. So if I have my box right here, if I create a client cache, all of my applications will connect to the same client cache. So in a web garden scenario, it makes more sense to use out of process client cache. But it can also be in process. With in process, it sits inside your application, and we have a plan to run tests with InProc as well as OutProc. So first of all, keep in mind that we took 26.5 seconds roughly to complete our test number one, right? So I'm going to turn on out of process client cache for this particular cache cluster, and I'm going to show you the improvements. And this is without any code changes. I'm not going to touch my application at all, and still I'll be able to benefit from the performance improvements. So I hope client cache made sense. There's a question: client cache will be present on all clients. Is there a way not to have it on any specific client? Yes. So client cache by design, when you turn it on, it gets created on all the client machines that you have under the manager. But once you have client cache configured, you can turn on or off on any of the client machines. You can even do that within the applications on a certain box as well. You can create two different caches, one with client cache and one without client cache, so that your applications don't use client cache when they don't need to. And one thing that I wanted to highlight, I'm glad you asked this question. The main use case of client cache is more reads than writes. If data is not changing very frequently, in that case, you can bring it in the client cache and you don't have to go to the server cache. But if data changes, in that case, you have to change it in the client cache as well as in the server cache. So for updates, it is actually going to slow down your performance. For reads, it's going to really improve your performance. So use case for client cache is if you have more reads than writes, and this is why I have test one designed for reading performance. So I'm going to quickly run this test. But before that, I'm going to create a client cache. And if I have, say, two nodes, let me just under the client. Not too sure if I have service running on this box, but I'm going to try that. Very good. Now I'm going to turn on client cache, and I can just say demo client cache. I'm going to keep everything default here as well. Keep out of process for the first test, and I'm going to use 512. Client cache is a subset of the data that you have in the server cache, so I'm going to use half of the memory for this particular cache, and then I'm going to keep everything default, auto start set to true, choose finish, and that's it. So there was a question, you can individually turn on and off client cache on any of the client boxes as needed. So for example, if I had to disable client cache, I can, do that. Disable client cache on this box. So I can do that as well. All right, so same test. I'm going to clear everything from the cache, and this time what I'm going to do is I'm also going to add client cache counters. And before I run this test, I'm going to use list caches tool so that I show you that a cache actually gets created and gets started automatically as well. So now we have demo client cache, which is a local cache, and it's running on this box. And I should be able to see the counters of this cache so that okay, there's a question. If a client is connecting using server info in the code using NCache API without registering that machine as an official client, both on the NCache manager, will the client cache be created there as well? All right, that's a very good question. If you don't have a client registered in NCache manager, so in that case, when you create a client cache, NCache manager does not have any view of that client because you're using the server info directly inside the configuration. So NCache manager does not know of that client. So that client is sort of dynamic for NCache manager. So in that case, you have to copy client cache settings manually inside the configurations, or you use the API you create a local cache first of all, and then inside your API init params, you specify the client cache explicitly. So what I'm showing right here is the configuration approach. So it would work only if you have the client added under the manager. If the client is not added under the manager, in that case you have to manually copy the settings, or you have to make use of the APIs to explicitly use the client cache. I hope that answers your question. That's a very good question in regards to client cache. So I'm going to show you the counters. Demo client cache is created. These are older instances, and I'm going to choose OK on this. So this is my client cache, and same test. I'm not going to change anything. I'm just going to run it. And this is going to add data into the client cache as well as into the server cache. So I'm interested in the count. I have to hit enter in order to add data. Yeah, now it's adding. So it's adding here as well as here. So this is our master copy, but we also have a local client cache which is being populated as well, right? So count is going up. So all 5,000 items would be added here is, and that's the architecture. If you don't have anything in the client cache, you would fetch it from the server cache. But if you already are adding, so it would add into the client cache into the server. And this is why it's slower for updates, but it's a lot faster for reading data out of the cache. And I'll show you in a bit. So we have activity going on here as well as here, so everything looks good. We'll wait for this test to complete, and next thing I'm going to do is I'm going to show you these counters right here. I'm sorry, I think I can do this. Yeah, should not have done that. I might as well run it one more time. I would give up. All right, so this clears the contents, and then it would add items to the cache. So there you go. All right, so as soon as items get added, and now client cache is being utilized, as you can see, count is being built up. And since I cleared the cache in the code itself, so it cleared the client cache along with that. So as soon as this gets completed, I will run the test for retrieving the same items. And notice the magic number that we had, 26.5 seconds, and this is in seconds that I'm calculating. Now with client cache, let's see how much performance gains it achieves. So 4,000 items are added into the client cache, and of course into the server items are being added. So momentarily we'll reach 5,000 item marker, 28 here and about 23, 24 on the other server. So 5,000 items are added, and now I'm going to retrieve these items from the. For some reason it does not give me control back. There you go. Now it's going to calculate the performance, and I would show you how much time it took to. It will print it right on the screen as well. There you go. So from 26.5 to 13.22. So it has half the total time it was taking before the client cache, and it was only a configuration. And how we did that? We simply made use of the local client cache. So all the requests were encountered were being handled from here, because all the 5,000 items that I was interested in retrieving were available in the client cache, are still available in the client cache. So each time I run my code, this would always take the same amount of time, right? So 13.2 in comparison to 26.5 seconds. So that's the first feature, and this is only with out of process. I'm now going to show you the same test with in-process client cache. Please let me know if there are any questions. For that, what you can do is you can come here. You can remove this cache. That's the easiest way. I usually remove it and then recreate it. So it doesn't matter if I provided the same name, because I've already deleted it, demo client cache. And this test, I'm going to use the InProc mode. And this is our most popular feature, right? It gives you some dramatic improvements, and I'll demonstrate in a bit. InProc actually means that you would have a cache, since you have client-side libraries inside your application. So with InProc, your client cache automatically gets instantiated inside your application when you initialize the server cache. No code changes are required. You just need the configurations to have the client cache up and running, but it would be run, managed inside your application process, and that saves serialization and inter-process communication overhead, and that's significant First of all, your data is not across the network. Your data is inside your application, and on top of it, your application does not have to serialize, deserialize for every individual object. So if data exists inside the client cache, you don't have to serialize, deserialize, and you don't have to talk to another process. And that's where you save most of the performance, and I'll show you in a bit. So I'm going to keep 512 as the size. Choose next. You don't have to start it yourself. Close. I think we're good. So next I'm going to, all right, so I think we're done. Let me just run the same test one more time, and this should allow me to add items. And once I've added items, I should also be able to see the characteristics. I'm not too sure what happened here. Let me just close it down. There you go. I think. All right, so now it's adding items, and I can see those items here, right? And I can also see the instance of the client cache, because the auto process has a separate instance. Now we have InProc client cache, so it would have a separate instance for it. I'll quickly show you this using this, and these are the instances of client cache. There are two because I ran the application twice. I was impatient on that. Right, so one of this would have activity. The other one is redundant because application started and stopped, so that got, you know, deallocated as well. So we have about 5,000 items in the InProc demo client cache. This is a process ID in the port on which it gets instantiated, but it's part of the same application. Now wait for the magic to happen, because this is when we really see the performance improvements. So with this, I'm just going to hit enter. It's too fast. So I want you to keep an eye on to one. I'm going to keep it here. All right, so I'm going to keep this window here. So I want you to keep an eye on fetches per second. There you go. So this counter right here, second loss, because it is going to be too fast in comparison. I'm having a hard time, by the way, managing this. Right. I think you can see the second counter here, and I'm going to hit enter on this. There you go. It's almost done. 0.05 seconds. So same test took about 0.05 seconds. I'm going to run it one more time so that you actually see this, and this time a new instance of the client cache would be instantiated. So I'm going to add that back. It's going to add items into the cache, and then based on that I'm going to use the NCache instance to select all instances here. Some are already in the cache. There you go. So which one is being utilized? Okay, so I can get rid of rest. There you go. All right, so there's a question, how does the InProc client cache stay synced with main cache? Is it a heavy task, and is it periodic? There are two sync modes. One is based on each operation. So that is pessimistic approach. That's heavy. So before every update or before every fetch, you consolidate or get the version information verified from the server. And there is event based as well, where we also rely on events. So there are two sync modes. Obviously event based is and there's a polling mechanism as well. So these modes, based on their nature, polling is faster. It's not that it does not impact that much on the performance, but this pessimistic mode where we check the version first, that really does impact. So again, keep an eye on the fetches per second. It'll be too quick to see that. There you go. So all five items in 0.06 seconds. So if I have to build a case for this, right? So we took about 26.5 seconds with baseline NCache default operations, default settings, default operations. We kept the same operations. We turned on client cache, and it brought it down from 26.5 to 13.22 seconds, halved the complete time. So that was the improvement that you achieved. And then we turned on InProc client cache, and since it takes the serialization and inter-process communication overhead, same task took 0.06 seconds. That is, within milliseconds, to be honest. So within milliseconds, about in sub-milliseconds for individual operations, you can introduce a local client cache and you can get the performance benefits out of it. So this completes our first trick for optimizing NCache performance, keeping the same use case but experimenting with client cache features in two different options. Please let me know if there are any questions. I'm going to quickly move on to our next feature, the second trick that we have. But before that, please let me know if there are any questions. I hope you liked client cache in regards to performance benefits that it has brought into it. All right, so next I'm going to use same test, right? Let me just have a look at the test. Okay, test 2. All right, so so that's for bulk. Okay, so I'm going to use the same test for test number 2 as well. But this time, we already know it took 26.5 seconds with the base line numbers. So I'm going to get rid of client cache so that it does not impact anything. I have the same cache available. I'm just going to clear the contents. And I can just run with the next trick without any issues. Let me just, refresh. And let me also refresh this. Actually, I can get rid of this now. I just wanted to answer a question that you can turn on client cache, on and off client cache for certain boxes within your environment. Okay, next feature that we have is compression. We have a feature which allows you to compress your objects automatically. Typically, what we recommend is that with NCache, you should have smaller objects that you should play around with. Smaller the object, better the performance. And why? Because you would be dealing with less size of the packet, which travels between network, client and server, right? And then server stores objects. So if a smaller object is there, storage overheads, optimize the performance. So that overhead would be less and overall performance would be improved. So with compression, we use gzip compression. It's done on the client side. So you have a client compressing data and your client is also decompressing data. So in essence, it's doing more, but after certain size, say 50 kilobyte or more, the object is big enough that when you send a bigger object, it takes more time. So it gives you benefits if you compress and decompress it, although you're spending more time on that. But overall, network trip and the storage optimizes the performance. And I'm going to demonstrate that in a bit. What I'm going to do is I'm going to come here. It's a hot applicable, so it can be applied on a running cache. I'm going to just scroll this right here. All right, so I'm going to go to the options, right? And I'm going to enable compression from here. Now, nice thing about this feature is that it simply can be turned on the fly. We use gzip compression. All we need to do is provide a threshold. So any object greater than 50 kilobyte, only then it would be compressed. In my case, I have all the objects greater than 50 kilobyte since I wanted to, take most of it, most of the advantage out of this feature. So I intentionally provided 100 kilobyte the object size. I'm now going to use hot apply configurations. With 50 kilobyte, and I'm going to use hot apply configurations, and this would apply it on a running cache. So my cache is empty, and I would also highlight one important detail here, since I would like to show you the compression and decompression counters as well. So if I come here in the client, I have the demo cache, and there's no client cache or any other feature here. I'm just running the same application test with client cache turned off, but compression turned on. So I'm going to add items, and if I show you the counters here, it's taking about 1600 microseconds, about 1.6 milliseconds on individual items. So 5 out of 5 milliseconds or out of 3.6 milliseconds is taking about 1.5 for compression. So half of the time is spent on the compression. And then there's a serialization going on as well. But best part about this is that it has compressed items, right? So now object size is smaller, and I should have shown you that. Let's rerun it so that I also show you the size after the compression. Let's clear the contents, and I'm going to run this one more time. And if I focus here, there is a counter which says average item size. There you go. So average item size is 100 kilobyte, but compressed item size is 278 bytes. So that's a huge improvement in size. Size has gone down. Now we're dealing with 278 bytes for individual objects instead of 100 kilobytes. So that sort of improvement actually gets you the kind of performance that we're interested in. And now I'll show you the same test with add, and it would retrieve, and you would see that it's taking some time to decompress, but it should complete the test and it should give you the performance gains in regards to this. So let's wait. There you go, 14.1 seconds. So from 26.2 seconds, 26.5 seconds, that was a baseline. We simply turned on the compression, and since we had a bigger object, so that's the use case of it. If you have bigger objects, typically I would recommend that you break down your objects from bigger to smaller yourself inside your application. But in some cases, that's not possible. You have to deal with your existing code, and there's no room for changing the code. So in that case, you can simply turn on this compression feature, and NCache would take care of everything else. NCache would simply compress data before sending it, and on retrieval, it would decompress data. So in essence, since a smaller object is traveling between client and the server and being stored, so overall performance is optimized in response to this. And you can see from 26.5 seconds, we brought the performance or time down to 14.1. Performance has been improved. So that's our second trick. I hope you liked it. Please let me know if there are any more questions. I have 4 more tricks still in my pocket, so I'm gonna demonstrate those in a bit. So let me know if there are any more questions. All right, so next I'm going to show you the third trick that we have. All right, so what's the question? There's a question, does this extra compression overhead puts burden on client box in any way? Not really. I wouldn't actually say that. Although client is actually compressing and decompressing, but you notice that it was taking 1 millisecond to compress, and it's also serializing and deserializing as well, right? So it's not that much. But yes, client is doing one extra task, but in response to that, client is now dealing with a smaller object size. So your serialized stream becomes smaller. So the TCP socket send and response, that becomes optimized. So on one end, client is doing more compressing and decompressing, but on the other end, it gets relieved. So that's when you get the more benefit out of it as well. That's the performance boost that you get out of it. So I would say it's negligible. I would say it's optimized. Client is doing less in comparison. Please let me know if there are any other questions. All right. So now next is we're done with the configuration part. I'm going to show you some APIs that you can use, and you can use some APIs, and those APIs would actually help you improve performance. So we have bulk operations. That's a very popular API, and for that we have test number 2 designed for it. I'm just going to set up this. Now it works in such a way that, let me just talk about the use case details. So for bulk, there could be scenarios inside your application where you may have to add a lot of items in the cache, or update a lot of items, or remove a lot of items into the cache, from the cache, and then you may read a lot of data back. A typical example would be all the products displayed on a product catalog page. So you may query the database, you construct your products objects, and then you have to publish all the products on a page. Similarly, when you need to update those products, you may update all of them. There could be price information that may need to be updated at once, right? So if there is a task where you need to do some batch processing, many number of items need to be updated at once. Typically, what would you do is you would simply loop through, right? And you would call cache.insert as many times as you have the number of items. So that's option number one. So this particular test, what I'm doing is I'm using bulk. Size of the bulk is 10 kilobyte object. I'm using 10,000 of those objects. So object count bulk, let me just see the, yeah, so 10,000 items are being added in the loop, being updated, and then I'm retrieving all those 10,000 items at once, calling cache.get. And then what I'll do is I'll clear the contents, and I'm going to use the bulk API. Bulk is very similar, very simple. You construct keys, and then you construct your objects, and then you call one API, right? So cache.add bulk or insert bulk, and then you call cache.get bulk to get all the items back. So one API, one operation can take care of all your 10,000 items at once. And nice thing about this is it's a lot faster because the idea is same. It's saving your individual trips back and forth between client and the server. It just takes the data at once, serializes it, and then puts it in one packet and sends it to the server. And server handles this as a single packet, and on the server end it distributes data to all the servers and add those individual operations as needed. So behavior is exactly the same, but overall performance is improved. And on retrieval, you get one packet back to the client. So one request and response can take care of all your items. And in essence, you improve your performance. And I'm going to show you this in a bit. I'm going to run this test and you would see some performance numbers in a bit. Okay, there's a question. Are items added with bulk API separate items in the cache, or are they as one item? Okay, these are separate items in the cache. It's just a way of performing those operations at once. But like I said, the behavior is exactly the same. So these would be individual items added into the cache, but you're doing them, you're adding them in bulk into the cache. All right, so I have press anything to add 10,000 items, 10 kilobyte objects. So I'm just going to add the items, and I'm going to show you. So basically, I should actually clear the contents first. Let me just remove it. All right, because I'm using the same keys, so I don't want to overwrite anything because that may impact the performance. So in this case, I have a separate baseline. I'm going to show you these numbers one by one. And by the way, one more thing that I need to do is I need to turn off compression. I'm using compression, so I don't want to impact that, although it wouldn't, but yeah. Okay, so I apologize for this. I think we're good. Yeah. All right, so I'm going to run this one more time. There you go. Adding items now, and it should start adding, and you would see the individual items get added, although it's one operation on the cache, but these are being added individually. And on the client side, we have average microsecond per insert. Item size is 10 kilobytes, and we have items being added from these are client side performances. And by the way, these are individual items. I apologize. This is not being done in the bulk as yet. So this is a test where I'm adding 10,000 items individually, and time it took was 17.8 seconds. Now I'm going to retrieve those items, and I'm going to show you the baseline for retrieval, how much time it took to retrieve these items back. So these are individual. This still is the same test. It's adding 10,000 items one by one, and that's why we saw the performance numbers, and then it's retrieving the same items one by one, and we'll see the time it took. So 17.8 and 18.5 seconds. Now it's doing the same in bulk. It cleared the contents, as you can see in the code. Yeah, so it cleared the contents of the cache, and now it's populating all those objects. You can see those items have been added. So these are new items, by the way, which are being added. And it took, let's see how much time it takes. For some reason it got stuck. I'm not too sure why it got stuck. This is happening today, that Visual Studio does not move from a certain point onwards. So let me just close it down. I think I should be able to run it one more time, clear the contents, and this time I would not switch screens. I would just stay on one screen. I think that should help. So adding items now. We have about 15 minutes left, so I want to cover 3 more features. So okay, so it takes 17 seconds. Now I'm retrieving about 10,000 items individually, so that would just set as a baseline, and then I'm going to show you the bulk overview of that as well. There you go. And it's automatically started the bulk test, and 2.9 seconds for add, and 3.18 seconds for the get, right? So that's the kind of performance improvement from 17 seconds to 2.9, and from 18.6 to 3.1 seconds. So that's what you get when you start using the bulk API. And I've already explained the use case. Since we have short time, so I'm going to move ahead with async operations. This tackles whatever we discussed so far, tackles the get use case when you're fetching a lot of data from the cache. Let me just close this application down. There is a way where you can optimize your transactional operations as well. For example, you add data to the cache, you update data, and then you also remove data from the cache. So if there's a use case where you can rely on the cache to update data in a asynchronous manner, these are the APIs for that. And for that, we have test schedules right here. I'm going to use test number 3. Let me just show you the details of that. It adds items through regular inserts, gets you the time for that, and it removes those items through regular APIs, and then it performs the same test using insert async API and remove async API, and it will give you a comparison. Since it's pretty straightforward, we've already established how my application works, so I'm just going to run it. I'm not going to move screens because that's something which Visual Studio does not like. So in this case, 5,000 items, 100 kilobyte object. It would take about the same time, but I'm comparing the performance numbers as well. So these are individual adds or updates, and then individual removes. Regular APIs, add, cache.add, cache.update, cache.remove, and then we'll be using 25 seconds. That was expected. Now it's removing all those items at once. Now remove actually is expensive call, because when you call cache.remove, it actually fetches the data back for one last time. There's cache.delete, which actually deletes data, so that's more optimized when you don't need the data back for one last time. We'll remove the items, and then I'll show you the comparison with async operations when we would rely on cache, and it already has started the async. So async actually adds data to a queue and then returns. Your application does not wait for that operation to be complete on the server end. It actually returns code right at that point. So you can see 25 seconds to 13 seconds, it has it is 50% of the time that was taking previously. So it's very improved in comparison. And then the remove part is 0.5 seconds from 26.2 seconds. So it really picks up your performance, where it actually improves the overall view as far as application is concerned. So application moves on. You would not get any exception as well. That's the downside of it. But there are ways where you can set up callbacks to get notified whether that operation get completed on the cache or not. So you can get notified, but in typical scenario, your application would just notify cache that here's an API, here is a packet that I need to add into the cache, update in the cache, or remove this object from the cache. And then it would just return. It would just pass on control to the cache, and cache can take it from there. I hope that was helpful. So that was our trick number 4. Now next, I'm going to show you the compact serialization. Since we have about 10 minutes, so I'm just going to complete this. I will try to complete it in as quickly as possible. Now, compact serialization, the main benefit of compact serialization was to serialize your objects without any code changes. You don't have to make code changes for serialization, but it has a associated benefit of uh, optimizing the performance, because it improves your serialization overhead by creating a serialization stream which is smaller in size. It's compact and it's faster to execute. So it uses the same concept as of compression, where the serialization stream is smaller. But since serialization is only one aspect of overall client to server communication, so it gives some improvements in the performance. So I'm going to run this test right here. Compact serialization, that's the sample. I'm just going to open it as is. So this is a sample which comes installed, by the way, so you can experiment with this sample right away as needed. All right, so let me know if there are any questions. I'm running short on time, so I would try to complete it within the allocated 1 hour marker, but let me know if there are any questions. All right, in the same test, I'm also going to use the dual NICs feature. So that's a feature which actually helps you on the capacity side. And in return, it also improves your performance. That's our trick number 6. So trick number 5 is compact serialization. Trick number 6 is dual NICs. Now, dual NICs work in such a way that you have two kinds of communication going on between NCache: a client to server, and then servers are talking to one another as well. Typically, you would have one NIC for both communications. But with dual NIC, if you have two NICs on one server machine, you can route client to server communication on one network interface card and server to server communication on another network interface card. And since you're distributing load between two hardware resources, that improves your capacity. Now you can handle more request load, and then you're actually distributing the load. So in return, you also improve your performance. So that's our trick number 6. So I'm going to show you compact serialization first. It takes demo cache. I'm going to run this sample real quick. It would add some items and it would calculate the time for those objects. There are multiple objects that this sample experiments. And then I'm going to turn on compact serialization for the same. Please let me know if there are any questions. This is a pre-installed sample which I'm just using from the command line. So it's using small object, 512 bytes. And then it would use a bigger object, medium object, and very big object. Even 512 bytes is a bigger object. We were experimenting with 100 kilobyte object size for most of our tests. And just to let you know, the 6th trick, dual NICs, you set up the NIC from here. Select network interface card. You set up one NIC for client server communication and another NIC for cluster communication. So that's how you would distribute load. So that's trick number 6 because we have less time available. So I wanted to cover this real quick. All right, so it took about 27.6 seconds for 512 items, kilobyte items, 10 seconds for this, and all the other tests would take about 10 seconds. And towards the end, I will set up compact serialization for the same objects. First benefit is that you don't have to have any code changes. You don't have to decorate your classes with serializable tag. So without any code changes, you can get the serialization and deserialization done. NCache is an out of process caching system. So applications need to serialize your objects, and you have to have your objects marked as serializable, or you need to have serialization or deserialization algorithm implemented. So this is the performance. I'm just going to save it somewhere, right? I should save it right here. Let's say text document, perf results, and I'm going to just paste it here for reference. All right, now I'm going to do a compact serialization settings. I need to stop this cache first. So it's without any code changes. All you need to do is set up your types with NCache. Your cache needs to be aware of your types, and at runtime, NCache would generate the serialization and deserialization code. So pre-compiled code is available. NCache just executes the serialization using the code in memory. So it's faster in execution, and overall serialization stream is something which is smaller in size. Now .NET serialization is pretty optimized as well, but you still get some performance benefits, which I'll show you in a bit. So I'm just going to add the complex serialization type here, add class, select all of these because we're experimenting with all. All right, actually this is slightly confusing. Here you specify the attributes that you don't want to be serialized through complex serialization. So all you need to do is choose add class and choose OK, and right click and choose apply configurations. That's it. Now I'll just start this cache cluster and I'll run the same test and already have some performance numbers there. All right, so it's started. So I'm just going to run this test real quick. Come back here, show you the statistics. Okay, so we have some activity going on. So that's really good. And in the meantime, please let me know if there are any questions. So this was our last trick within the available features. There's some more optimizations that you can opt based on your use case best practices, but these are very specific performance improvement features within NCache, and we experiment with these all the time. You've seen client cache dropping performance from 26 seconds to 0.05 seconds. There was a client where it was taking 46 seconds to complete a task, and then we turned on client cache, it brought it down to 9 seconds, and then we turned on InProc client cache and it brought it down to 0.06 seconds. So sub-millisecond responses for huge objects in size. So bigger the object, better the gain, greater the gain out of the performance numbers. I think it got stuck. I think whenever I see this white dot here, and this gets stuck. So I'm going to run this one more time. And I'm not going to move my cursor here. For some reason, if I move my cursor, I think the Visual Studio gets stuck. So I need to get this verified. But I'm hoping to get this done, and then we can conclude the presentation afterwards. Yeah, so 9.12 seconds. Let me just open the results here and let me just compare it. I hope this completes. Yeah, so from 27 seconds to 9.12 seconds, so that's when you got the most performance boost. And rest 10.0, 9.8, 10.2, 9.2, it's still faster, but it's comparable, right? But for smaller objects, that's when it actually gave you the bigger advantage. So it does improve performance in comparison to regular .NET serialization, and on top of it, this is a no code change option. That's the primary benefit that this feature brings in, that without any code changes you can serialize and deserialize your objects, and you don't have to make any application side code changes. So 9.3 to 10.2, so about 1 second faster in comparison to regular .NET serialization. So that has also improved the performance. And like I said, the sixth feature was to use dual NICs. 2 NICs for distribution of your data from client to server communication on one network interface card and server to server communication on another network interface card. There's more to do with capacity, and then it also improves your performance. So that completes our topic today. We had a lot to cover. I'm glad I was able to do it in 1 hour marker within time. So I expect that it was informative. It was something that showed you some new aspects of NCache. So please let me know your feedback. Let me know if there are any questions. We'll just wait for 1 more minute for any questions that you may have. Although you were very active, all of you, asking a lot of questions, but please let me know if there are any other questions at this point. If there are no questions, you can there are some things that you can do towards the end. You can download a fully working 60-day trial of NCache from our website. It's a fully working trial. You can get hold of our tech support team for any questions, for any hand-holding sessions that you may need. And then you can also get in touch with our sales team for any sales-related questions. For those of you who initially registered and finally joined, thank you very much for your time. It was a player presenting NCache webinar. I'm just going to conclude this because we're already above our allocated time marker. So once again, thank you very much, everybody, for your time. It was a player presenting NCache webinar to you. It was a hands-on, topic, and I'm very happy to be able to present this. So once again, if there are any questions, please let us know, and we can always take it from there. Everybody, thank you for your time. Take care. Have a good day. Take care. Bye bye.